You sit through an hour of video conferencing, hash out details of a project, and the moment you click Leave Meeting, reality sets in. Your reward for surviving that 60-minute conversation is an entirely new, cascading list of tasks you now have to complete. We call them action items, a corporate euphemism that sounds productive. In practice, an action item is really just a delayed penalty for having a meeting in the first place. You've spent the hour talking about the work, which means the actual work still has to happen later. But consider an entirely different mechanical approach. What if the casual, back-and-forth dialogue of a group call was the exact mechanism that completed the work while you were still speaking? The modern collaborative workflow breaks down because we treat meetings as a staging ground for future effort. We plan, we assign, and then we wait. A team of developers, Jake, David, and KK, decided to test a different model. They wired a voice-activated artificial intelligence directly into a local computer environment, and then they jumped on a standard video call to see what it could do. If you trace the path on this flowchart, you'll see how bizarre this technical setup actually is. One developer is sitting at his desk, speaking normally into his microphone, and his voice travels across the network to control a teammate's local machine. He has direct access to a private local database folder halfway across the world, using only spoken words. Claude Code, an AI built for complex programming tasks, listens to the call through a command line interface. It functions as a working participant, actively modifying code based on the team's spoken directions. By giving an AI voice recognition and local system access, the nature of the call flips. It ceases to be a passive discussion. The meeting room becomes a real-time shared command center. The testing environment Jake provided for this experiment was no lightweight folder. It was a massive, highly complex database originally constructed for psychometric research at the University of Edinburgh. He calls it the ethics engine. It's a localized web application designed specifically to test various AI language models by feeding them standardized psychology questionnaires and analyzing their responses. Looking at these 4 Rorschach ink blots, you can see the type of complex visual psychology assessments the engine is built to process. The application parses the responses generated by the models against these inputs and converts them into hard numerical scores. With the environment set, the team begins the live test. Over the call, KK simply asks the listening agent to look through the repository and figure out which common testing scales they haven't included yet. The agent doesn't just pull a generic list from the internet. It independently reads through the structure of Jake's year-long master's thesis repository, analyzes the existing code, and contextually cross-references it to locate meaningful gaps in the research design. The AI responds audibly with 7 relevant options. It specifically recommends adding a test called the Dark Triad, a recognized psychological instrument used to measure Machiavellianism, narcissism, and psychopathy. KK agrees with the recommendation. He tells the AI out loud to go ahead and add the scale to the engine. That casual spoken sentence immediately kicks off an autonomous coding sequence. The AI instantly writes back-end code to inject the Dark Triad scale. Simultaneously, it updates documentation, incrementing validated scales to 12. The diagram transitions. Unprompted, the AI evaluates the front-end UI, realizing the 27 new items will display as one massive list. The agent speaks up on the call, noting that users won't know which specific traits the questions belong to. It proactively offers to code in subscale support, breaking the user view down logically into the 3 distinct traits of the Dark Triad. 2 humans agreed on an idea in conversation. Seconds later, back-end database code was written, the master documentation was updated, and a nuanced UX design improvement was pitched and ready to deploy. Jake and his team maintained this workflow for roughly an hour. The total cost of running that hyper-productive session, using a custom AI voice routed through the 11 Labs API, was exactly $1.20. That price is based on current premium tooling. By migrating the voice integration to open-source models like Voxel, the operating cost drops so low it effectively approaches zero. Compare $1.20 to the overhead of a traditional corporate structure. You have the hourly salaries of everyone sitting in the meeting, the lost productivity of planning the work, and the days or weeks of lead time required for an engineer to actually sit down and write the code. We have the computing power, and the financial cost is negligible. The only friction left in this process is our reliance on old habits of collaboration. Jake's ultimate goal for this technology is to embed it into the fabric of everyday conversation. He envisions structured workflows that activate automatically the moment specific keywords are spoken in a meeting. He calls it the interruption engine. Imagine a team debating a feature solution over a video call. Before they even finish deciding who should take on the task, the listening AI politely interrupts the conversation to announce that the code has already been written and deployed. Meeting transcripts currently serve as historical logs, but this technology turns them into active command lines. Instead of documenting what was said, the transcript executes work as the words are spoken. When the gap between discussing an idea and deploying the code drops to 0 seconds, the corporate action item becomes obsolete. We stop planning to do work and finally just do it.